Welcome to Spaceverse, your portal to cosmic adventures. The universe has a way of surprising us. Even in death, stars leave behind wonders that shape the very fabric of existence. And one of the most breathtaking examples of this is the Butterfly Nebula, a spectacular celestial death blossom that continues to teach us how stars live, die, and ultimately recycle themselves into the building blocks of new worlds. The Butterfly Nebula, also known as NGC 6302, sits about 3,400 light-years away in the constellation Scorpius. At first glance, it's easy to see how it got its name. Two massive lobes of glowing gas billow outward like wings, while a dense, dark band slices through the middle, forming the body of this cosmic butterfly. But what we see as beauty is really the dramatic aftermath of a star that has run out of fuel. And now, thanks to the James Webb Space Telescope, astronomers are uncovering just how crucial these dying stars are in shaping the planets, and maybe even the life that come after them. NGC 6302 is what astronomers call a planetary nebula. Don't let the name fool you, it has nothing to do with planets directly. Instead, it marks the final stage in the life of a sun-like star. After billions of years of nuclear fusion, the star exhausts the hydrogen in its core. Without the energy to balance gravity, it sheds its outer layers into space, forming vast clouds of gas and dust. At the heart of this nebula lies the leftover stellar core, a white dwarf that burns at an astonishing 220,000 degrees Celsius, or about 396,000 degrees Fahrenheit. It's one of the hottest stellar remnants we've ever observed. What Webb has revealed in the Butterfly Nebula is extraordinary. Using its mid-infrared instrument, or MIRI, scientists have peered deep into that central dark band, a torus of dust and gas seen edge on, and uncovered something we've never witnessed before: the active growth of dust grains that are the essential seeds of planets. Interstellar dust is usually extremely tiny, just about 0.1 microns in size, far smaller than the thickness of a human hair. But in the Butterfly Nebula's torus, Webb detected grains of crystalline silicate dust roughly a millionth of a meter in size. That may still sound unimaginably small, but it's significantly larger than what astronomers typically find drifting in space. And here's the crucial part: these grains are comparable in size to the dust particles we see in planet-forming disks around young stars. In other words, Webb has captured the moment when the raw materials for planets are being forged, not in the nursery of a newborn star, but in the dying breaths of an old one. This is a revelation because for years, scientists debated how cosmic dust grains actually grow large enough to serve as planetary building blocks. We knew that dust from dead stars mixes into interstellar clouds, eventually seeding new generations of stars. But the mechanics of how those dust grains coalesce and grow had remained mysterious. Thanks to Webb, we now see that dying stars themselves, in their final outbursts, may be sites where dust grains mature and prepare to take part in the birth of future planets. Mikako Matsuura of Cardiff University, who led the JWST observations, explained it perfectly. This discovery is a big step forward in understanding how the basic materials of planets come together. With Webb's sharp infrared eyes, we're witnessing that process directly. And it's not just ordinary dust. Webb's instruments also picked up the presence of quartz crystals in the Butterfly Nebula's dusty torus. Yes, quartz, the same mineral you might find in gemstones here on Earth. The fact that quartz can form in such a harsh, alien environment tells us something profound about the complexity of chemistry happening inside nebulae. Even more fascinating, the nebula revealed two distinct types of dust formation. In some regions, calm and stable conditions allow the slow growth of crystalline structures like quartz and silicates. In other regions, violent and fast-moving outflows created a different kind of dust, more chaotic, less ordered, but equally vital. As Matsuura described it, Webb allowed astronomers to see both cool gemstones formed in calm, long-lasting zones and fiery grime created in violent, fast-moving parts of space, all within a single object. It's like peeking into both a jeweler's workshop and a cosmic forge at the same time. But the discoveries didn't stop there. Webb also detected something called PAHs, polycyclic aromatic hydrocarbons. If that sounds familiar, it might be because you've encountered them in everyday life. On Earth, PAHs are found in burnt toast, car exhaust fumes, and even the smoke from a campfire. But in space, these molecules are widespread, and they play a crucial role in cosmic chemistry. PAHs are carbon-based molecules with ring-like structures, and they're suspected to be key players in prebiotic chemistry, the kind of chemistry that could eventually lead to life. Finding them in the Butterfly Nebula means that this dying star isn't just creating the building blocks for planets, it's also producing some of the complex molecules that may help jumpstart biology on those worlds. How do they form in such an extreme environment? Astronomers believe the PAHs in the Butterfly Nebula come from bubbles of particles blasted out by the central white dwarf. As those fast-moving outflows collide with surrounding gas, the energy and shock waves trigger the formation of these flat, ring-shaped carbon molecules. It's a striking example of how chaos and violence in space can give rise to molecules that might one day be part of something as fragile and delicate as life. The Butterfly Nebula is more than just a pretty picture in the sky, it's a laboratory for understanding the cycle of matter in the cosmos. Dust from dying stars like this doesn't stay trapped forever. Over tens of thousands of years, the nebula will fade, its glowing wings dispersing into the void. But the dust grains, quartz crystals, and PAHs will survive, drifting silently into interstellar space. Eventually, they'll find their way into molecular clouds where new stars are born. There, they'll become part of protoplanetary disks, sticking together, clumping, and slowly forming pebbles, planetesimals, and ultimately full-fledged planets. In a sense, what Webb is showing us is cosmic recycling in action. The death of one star plants the seeds for countless new worlds. And who knows? On one of those future worlds, perhaps life itself will emerge, made possible by the chemistry set in motion inside a nebula like this one. It's poetic, isn't it? A star dies, but in its death throes, it gives rise to the materials of creation. The Butterfly Nebula embodies both destruction and rebirth. Its wings may fade, but the dust and molecules it leaves behind will carry on, ensuring that the story of the universe continues. The results of these groundbreaking JWST observations were reported on August 27th in the journal Monthly Notices of the Royal Astronomical Society. And while the Butterfly Nebula will eventually disperse and disappear from view, its legacy will live on in the stars and planets yet to be born. So the next time you look up at the night sky, remember this. Every atom, every dust grain, every molecule has a story. Some come from stars like our Sun, others from titanic supernova explosions, and still others from quiet planetary nebulae like the Butterfly. The very stuff of our bodies, the carbon in our cells, the oxygen in our lungs, the calcium in our bones, all of it was forged in the hearts and deaths of stars. The Butterfly Nebula is just one dazzling reminder that the universe is always weaving the threads of death and life together. And thanks to the James Webb Space Telescope, we can now see those threads with stunning clarity, watching as the tiniest grains of dust begin their journey from the ashes of a dead star to the possibility of becoming part of a living world. Out there, the Butterfly Nebula reminds us that even in death, stars leave behind the seeds of new worlds, dust, crystals, and molecules that may one day spark life itself. Here on Spaceverse, we'll keep following these stories of cosmic endings and new beginnings. Stay curious, keep looking up, and I'll see you in the next journey through the stars.